So we're going to do a definition for a proportion. So we've been looking at proportional relationships. We're going to look at what is a proportion when we use it like a noun instead of a verb. So proportion is an equation with two equal ratios. Or you might think of them as fractions. So I'll leave this up here for a little bit, let you get that definition down. So it's an equation with two equal ratios. So it looks something like this. A over B equals C over D. And we're not going to focus on solving them today. We're going to focus on deciding if something is proportional, using a little bit different technique from what you've seen before. And I'm going to show you how we can use proportional reasoning to decide which fraction is better without having to make common denominators or look at decimals. So it's kind of a quick little tip that you can have. Okay, so keep writing. If you're done, just hang on. I know it's not exciting to wait, but we wait for each other, and that's okay. Okay, everybody got it? So down here, we're going to state if each pair of ratios forms a proportion. So what the rule is, the extremes equal the means, which is like, what? And this is like, if I take A times D, so A times D is called the extremes. And the only time this has ever really come up is Knowledge Bowl, but I'll give it to you. And that's got to equal B times C, which they call the means. You do not need to necessarily know extremes and means for a test in my class. Like I said, we had a Knowledge Bowl question on it at the last high school meet, so that's a place where it sometimes comes up. But let's look at what we're talking about. If I have two fractions, I'm trying to decide if these are proportional. So what I'm going to do is I'm going to take these and multiply. So 9 times 2 is 18, and I'm going to put it up here. There's a reason why it's going up there. And then 3 times 6 is also 18. So if those come out the same, then that means it is a proportion. So that one is a proportion. Or you could write yes. It's a little shorter. So that one is a proportion. So if I do this one, I'm going to have 4 times 9. What is 4 times 9? 36. And then I'm going to take 20 times 3. 60. So is that one a proportion? No. So that one is not a proportion. So I'm going to put not prop and abbreviate.
Can we just put no?
No and yes. It depends on how they ask the question, but the way this one is worded, I think that would be fine. Get a pencil with a little more lead. Okay, so down here, 15 times 4. I always think of 15 minutes like an hour. So if there's 4 15-minute increments, that's a whole hour, right? So that would be 60. And then 6 times 10 is also 60. So that one would be yes, it's a proportion. So you could put yes, you could put prop, either way. Okay, now we're going to start getting into some decimals. And here's where your calculator might come in handy. So we're not going to take time on this lesson to multiply these by hand. I know you know how to do it, but to save time, we're going to use our tool. So I'm going to take 2.4 times 2. That one actually isn't that hard, 4.8. And then I'm going to take 3 times 1.6. And guess what? That's also 4.8. So that one's not as easy to spot, but that one is proportional. So yes, we could multiply them out by hand, but to save some time, we're not going to, especially these where they're both decimals. So 7.8 times 2.3. So I'm going to make sure and write down the numbers that I get. That's how I can show my work here. And then, 4.6 times 3.9 is also 17.94. So that one is going to be a proportion. And I know some of you are working ahead. Does 7 end up being one or not? Nobody's tried it yet? Okay. That's all right. I thought maybe some of you are working ahead. So if I take 10.8 times 3.5, I get 37.8. And then if I take 21 times 2.7, I get 56.7. So that one is not proportional, or you could just put no. So this is a way that you can check if you've got two sets of numbers but you don't have a whole table. This is also a way that we can see if we have equivalent fractions. So says we're going to compare the two numbers using less than, greater than, or, and then the equals ended up down here. Oh well. So if we do this, I'm going to go up and across like this. So 3 times 4 is 12, and 5 times 2 is 10. So the reason that we have these going up and crisscrossing instead of down is because now I can do this. I have 12 and 10. Which one's bigger?
12.
So I'm going to put the greater than sign like this. That means 4/5 is bigger than 2/3.
Okay.
Isn't that cool? So, but you do have to go up and across, not down and across. Otherwise, you'll get the opposite. So if I take 8 times 3, I'm going to get 24. And 4 times 7 is 28. So which one of these is bigger? 28. So Cookie Monster or Pac-Man or the alligator, however you learned, is going to eat the 28. But that means 3/4 is less than 7/8. And in elementary school, you probably learned to compare these, 1, by making common denominators, and 2, maybe using little blocks and kind of seeing how they added up. This is a little bit faster, especially if you don't have access to those resources. Okay, so let's look at number 10. So I'm going to take 10 times 1, so hopefully that's easy, 10. And then 3 times 3 is 9. And so this is going to open this way. 10 is greater than 9, which means that 1/3 is greater than 3/10. And then on this last one, 10 times 4 is 40, and 5 times 8 is 40. And that means these are equal. So what that actually tells me is that these are equivalent fractions. You guys remember making equivalent fractions? You could look at this, and if you reduce 8/10, it would be 4/5, or if you multiplied 4/5 by 2 and 2, you get 8/10. So those are other ways. But think about the ones that have decimals in them. This is kind of a cool way to check things if you've got decimals and you're having to use a calculator.